east at 600 miles an hour, another traveling north at 750 miles an hour. If they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours?
Let's draw this picture.
Let's draw the picture.
You gotta make the box first.
Well, yeah, come on now.
I got
What do you think I am? Shot
one that's headed north and one that's headed east. One that's traveling east is traveling at 600 miles an hour, and the one traveling north is 750 miles per hour. Wondering how fast is their distance apart increasing? Got the picture modeled? I need an equation.
A squared plus B squared.
Yes.
C squared.
How about that?
Oh, they're done.
E squared plus north squared is equal to distance squared.
Right.
Yep.
Good with that?
Yep.
So, considering that situation, I do know E prime. E prime is 600. And I do know N prime, that is 750. What am I trying to find? D prime.
Right.
Let's take the derivative with respect to time and just see what we come up with and how we make use of this. What is the derivative of, let's see, I got E squared plus N squared is equal to D squared. Derivative of E squared. Derivative of N squared. And derivative of D squared.
D. 2D.
Oh boy, this is a problem. I've got E, N, and D that have popped up in the problem, and I'm not given E, N, or D, am I? But I'm given something in the problem that might lend me to be able to find. What piece of information am I given that I have not used? 2 hours. After 2 hours, how far would this plane have traveled?
1200.
1200. After 2 hours, how far would this plane have traveled? 1500. So I know that the current E is equal to 1200. I know the current N is equal to 1500. I can use that to compute D. Does everybody agree I can now find the current distance apart? I should use the Pythagorean theorem on my calculator, as I will. With that, I got 1200 squared plus 1500 squared. And then I will take the square root of that, and I get 192094.
So throughout all these problems, do you want us rounding to the?
I usually like to go to the hundredth.
Okay.
So I now have these pieces here. I can plug them in to solve in this one. I have 2 times the E value is 1200. And then E prime is 600. And then I have, what, 1500 times 750 equals 2 times 1920.94 times D prime. Well, there's a lot of stuff there, isn't it? I'm gonna make life easier on myself. That's how I operate. I notice that everything's being multiplied by 2, right? So I'll just get rid of the 2's, just divide it off. So at least I've reduced that piece. I'm less likely to make a mistake. So I have 1200 times 6 times 600 plus 1500 times 750. And then I have to divide that by 1920 point what? And I get 960.46. Good with that? Not too bad, right? A ladder is 12 feet long. It's sliding down the side of a building.
So loud.
Nobody's on it. The base of the ladder is moving at a rate of 1 foot per second away from the wall. How fast is the top of the ladder falling when the base ladder is 10 feet away?
Right, okay. Let's make our box. So we got the 4 boxes.
So my argument and what people have said is that they don't see the end of the problem, but if that, at least they make the boxes, it gives them somewhere where they start.
Exactly, yeah.
And so hopefully you find that to be the case. If you don't, that's okay. Just, just trying to give you guys tools to be successful. And I wasn't suggesting that you're being sarcastic. First when I saw the boxes, I said, I'm never gonna do that. That's just stupid.
Oh, I knew it.
And then I started teaching, I was like, what if I try using boxes? And without a doubt, it really helps organize work for me and for the students. That's grass. Okay.
You see it.
Red one is the
Realistic.
ladder. How do you want to label this? 12. I'll call height and base. Why can I put the 12 there? It doesn't change. Does everybody understand that? An extremely important concept in related rates. If it doesn't change, you can plug it in right away. If it's sliding down, does the height change? Does the base change? But does the length of the ladder change? No. So there we got it. Give me a formula.
Is it gonna be the same way?
It'll be Pythagorean theorem, yep. Because we're not referring to area. If we're referring to the area of the triangle form, then we'd be at that one. But this is, without a doubt, a Pythagorean theorem problem. B squared plus h squared is equal to 144. What am I given? Base is 10. The rate at which the base is moving away from the wall is 1. And what else do I know? Or what am I trying to find? H prime? Yeah. So let's take the derivative with respect to time of b squared plus h squared is equal to 144. What is the derivative of b squared?
2
Plus
2h.
equals 0. Sweet. Love it, don't you? Okay, mistake that people make, sometimes they just write 144, derivative of 144 is 0. I can divide through by 2, couldn't I? And so I end up with b prime plus h prime is equal to 0. I know what b is, it's 10. And I know what b prime is, it's 1. I'm trying to find h prime, but I don't know h, and I have to figure out h. How in the world? I go back to Pythagorean theorem, right? So I can figure out h yet. In fact, we don't even use our calculator because we're super smart. We just plug in 10 for h, and we get b squared plus 100 is equal to 144. Or rather, b squared is equal to 44. As we square root both sides, we get b is equal to 2 roots of 11.
Right.
Wouldn't that be H?
Yeah, sorry, I switched these two around. So my H is 2 roots of 11. And so we have 10 plus 2 roots of 11 times H prime is equal to 0.
Negative 10 over 2.
Yeah, so H prime is equal to negative 10 over 2 roots of 11. And so I'm going to try to get a decimal there, because that's the way I want to do it. And as I type it in, I also want to show you that you have to be careful, because we're going to take negative 10 divided by parentheses 2 roots of 11. Negative 1.507. So negative 1.5, and we are going feet per second. Not too bad. So you can see yesterday was a chance to get your feet wet with the format. You know what to expect with the format. Now it's just applying to different types of problems, right? So let's skip number 6. It's a dumb problem. Let's move to number 7. I want to try to do 7, 8, and 9. Boyle's Law. Are you familiar with it?
I haven't heard of it yet.
I've heard of it, I've already forgotten.
So the pressure and the volume multiplied to a constant given a gas in a within a certain area.
Yeah.
Okay, all right. So that is constant, remains a constant. So if you were to it has things to do with heating and temperature, right? So for example, suppose that you have a kettle of water and you are heating it. What is happening to the pressure? It's building, right? As the temperature rises, okay? Anyway, I'm not a science teacher. But this is the application. Boyle's law states that the temperature of a gas remains constant. Then the pressure, because I was talking about temperature changing, you're heating it up, a different application. Then the pressure and the volume of the gas will satisfy PV equals C, where C is constant. If the volume is decreasing at a rate of 10 cubic inches per second, how fast is the pressure increasing when the pressure is 100 pounds per inch squared and the volume is 20 cubic inches? Anybody else confused?
Yeah.
Yeah, I am too. Okay, so I try to just get started. Get started with my 4 boxes.
Always have those.
And what I try to do here is I try to model it by looking at a few examples. Pressure times volume is equal to a constant. So what things do we know so far in this problem? It says the volume is decreasing at a rate of 10 cubic inches per second. So what variable is that? V prime is negative 10 because it's decreasing. How fast is the pressure increasing? So what are we trying to find? P prime. When the pressure is 100, so that's 100, and the volume is 20. Everybody see that? So what we have is P times V is equal to, not C, but what? What do they multiply to? 2,000. 100 times 20 is 2,000.
Actually multiple. Oh.
So as I try to understand this problem, I realize that I have For example, I could have 100 times 20 is 2,000. I could have 20 times 100 is 2,000. I could have 1,000 times 2 is 2,000. I could have 40 times 50. You have all sorts of options, right? That's what's happening. This guy always stays the same. These change, okay? How fast are these changing? Notice that if the pressure drops, that the volume goes up. People see that? Okay. So in this case, we see that the volume is decreasing, so therefore the pressure should be increasing. Now, you don't necessarily have to do any of that, but I'm just trying to help you how to see the problem. When you don't know how to do the problem, just do the problem. Just kind of start plugging in stuff, working it out, okay? So I have pressure times volume is equal to my 2,000. I have my formula. I have my knowns and unknowns. I can now take my derivative with respect to time of PV is equal to 2,000. And who's going to be the first to say it?
Not it.
Wow. We got ourselves in a sticky situation.
Product rule. Thank you, Ty. P prime V plus V prime P is equal to 0. No problem to have the product rule because we have V prime and we're looking for P prime. So this all works out quite nicely. So we have 20 P prime, and then V prime is negative 10, so minus 10 times 100 is equal to 0. Or 20 P prime minus 1,000 is equal to 0. 20 P prime is equal to 1,000. If I divide both sides by 20, what do we get? 50.
I did in my head, but I had to double check.
Let's figure out our label. Pressure is measured in pounds per inches squared. So pounds per inches squared, and it's times and minutes in the denominator. So, because we want to do per minute, or per second, sorry about that.
Brings me back to my chemistry days. Chemistry days. So, take me back. Nothing's here.
You guys hanging in there?
Barely.
Okay, we got 2 more. Volume of a ball is increasing at a rate of 10 cubic centimeters per second. At what rate is the diameter increasing when the volume is 100 cubic centimeters per second? Well, this is more up our alley, isn't it? We've seen this before, haven't we?
Right.
Yeah.
My picture down.
And so we've got the ball, and Bea taught me how to draw basketball yesterday. So there we go.
I'm drawing it.
So the volume is getting larger. And the radius is increasing, the circumference, the surface area, the diameter, all that's changing, and it's all changing with respect to time. Our formula for volume of the sphere is 4/3 pi r cubed. Our known is V prime is equal to 10. Our other known is V is equal to 100. What is it that we are trying to find?
R prime.
R2.
Diameter.
D prime.
D
Why is this a problem?
because we don't know.
Because we don't know the rate.
We don't know the radius, and our equation doesn't involve the letter D. It involves the letter R. Wouldn't it be great if we could write an equation that had D instead of R?
We can.
How do D and R relate to each other?
Multiply by 2.
Yeah, we have R is equal to 1/2 the diameter, right? Well, could we simply not just substitute this in right here? And that would then give us an equation that involves D instead of R? I have volume is equal to 4/3 times pi times 1/2 D quantity cubed. If I left it like this, I would need to use the chain rule when I take my derivative. So I'm going to actually multiply it out. Volume is equal to 4/3 pi. What is 1/2 cubed? 1/8
Right.
D cubed. So I have volume is equal to, let's see, 4/8 becomes 1/2, right? So I'll have a 6 in the bottom. So pi over 6 D cubed. There's my new formula for volume when we are referring to the diameter. I take the derivative of this with respect to time. What is the derivative of V? What is the derivative of pi over 6 D cubed? Yep, 3 pi over 6 would be pi over 2. D squared, D prime. We have V prime. V prime is 10. Pi over 2. I now need to figure out what D is. How could I do that? Excellent. So the volume is 100 equals pi over 6 D cubed. So if we go to our formula, we just type in 100 for volume and we solve there. So I will multiply both sides by 6, I'll divide by pi, and I'll take the cubed root. So I go to my calculator, I have 100, I multiply by 6, I divide by pi, and then I take the cubed root of that. The way I like to take a cubed root is I raise it to the 1/3 power. That will do a cubed root operation, and I get 5.758.
Looking for more lead. Oh. For lead.
Right.
I solve for D, I'm going to multiply by 2, divide by pi, and then divide by the 5.758 squared. For my calculator, 10. Times 2, divided by pi, and then I divide by 5.78? Squared. I get 0.192. And we are measuring diameter, so we are going to go in centimeters per second.
Oh, that's true.
Mm-hmm. But we got it.
Our last tricky one of the day. Corn is going to be emptied onto a pile at a rate of 12 cubic feet per minute and is taking the shape of a cone as we empty it. How fast is the height of the pile increasing when the pile is 6 feet high and has a base diameter of 8 feet? Now, what's interesting about this, in order to make this problem work at all, is we need a couple things. Number one, we need the volume of a cone. The volume of a cone is 1/3 pi r squared h.
So we need to memorize that for the
Nope.
test?
Nope. Area of a circle, area of a rectangle, area of a triangle. The rest I'll give to you.
Okay, then we're good.
So I've got volume is 1/3 pi r squared h. And the other thing you need to know is that if we are emptying this corn onto like this pile, obviously it's going to continue to get taller and it's going to continue to get wider each time. But what we're going to say is that its height and its width, like it remains proportional. So suppose that it has a height of say 4 feet and that the width is, the diameter is 8 feet. So the diameter will be twice the height. So then if it's 10 feet high, it would be 20 feet wide. Get the idea? So we're going to assume that as we empty it, continues to just take that normalized shape. All right? So, what do you know in the problem? What are we given? The current height is 6. Does the height change?
Yes.
So we can't plug it in. What else do we know? Yep, the base diameter is 8. If we know the diameter, do we know the radius? Radius is 4. Do those things change as well? Yes, we can't plug them in right away.
The rates of the.
Yep, V prime is 12.
Wait, what does it mean?
'Cause it's
Volume. Corn is being emptied in a pile at a rate of 12 cubic feet per minute, so we get a volume measurement there.
Okay.
Okay, what are we looking to find?
The
H prime. At what rate is the height increasing?
Right.
Okay. So, what I'm going to do here is I'm going to use our current situation, which is this is a height of 6, and it is a radius of 4. To say that the height over the radius remains a constant ratio of 6/4. So remember how I said that they are proportional to each other, that that's going to remain constant? That's important because if we were to take this derivative right now, it would require the use of the product rule, wouldn't it? But the fact is the product rule would produce both r prime as well as h prime. We're trying to find h prime and we have no idea what r prime is. So therefore, we need to get rid of something. We need to get rid of r altogether because we want to come up with h prime. Could we use this to get rid of r? Yeah. If I cross multiply, I have 6r is equal to 4h. And if I divide both sides by 6, I get r is equal to 2/3 h. That ratio remains constant. So therefore, you could take this and drop it right to the r squared. And so I have the volume is equal to 1/3 pi. I'm going to square the r value and get 4/9 h squared times h. And finally, if I multiply this, I have volume is equal to 4 pi over 27 h cubed. Notice I'm always trying to write it so I can use the power rule if possible. I have a coefficient, I have a variable, and I have a power. Now the problem is a piece of cake upside down. Derivative with respect to time of volume equals 4 pi over 27 h cubed. The derivative of my volume is v prime. When I drop the 3 in front, that's going to change the 27 on the bottom to... Hi.
Hello.
How's it going?
Good.
Excellent. Here's your pass so you don't have to come slow them up. If I put the 3 in front, 3 over 27 becomes 1/9. So I have 4 pi over 9. What else do I have?
H squared.
Times h prime. Excellent. Those are all the pieces I need. V prime is 12. 4 pi over 9. H squared will be 36 times h prime. Ooh, I really like the way this problem is shaken out. 12 is equal to 36 divided by 9 is 4.
4.
Times 4 is 16 pi.
Basic math is hard.
And now if I divide both sides by 16, 12 over 16 reduces to 3 over 4. Divide by pi as well. So I've got a nice expression in terms of pi. I can also obviously come up with a decimal, which I will. 3 divided by parentheses 4 second pi, and I get 0.238. And my measurement is going to be in feet.
That's the last one, right?
And the reason why that is important is because if you had something that was delivering the corn onto the pile, okay, it's coming up and dropping off, okay, dropping off onto this pile, at what time does the auger need to be moved? At what time does it need to be changed? How fast does this need to be removed away so it doesn't finally overtake what it's dropping?
Could just time it out like one time.
You just watch it, you know?
Or
Except you have multiple people running around and trying to manage the plant, and you know.
We do this before we're operational.
you could just make the thing go higher.
Right, right.
All right, let's talk about your word problem so you know what to focus on, what not to focus on. Yesterday I told you focus on the level 1, those are the basic ones. Now it'll be problem 1 through 6. So today you're ready to move to kind of level 2 and 3, okay? And I'm going to have you circle some problems here that you could try. Problem number 7, number 9, 10, 11, 12. Flip it over. 16. And that would be it right now. We're going to eventually be able to work through a couple more problems, but not a lot. I do want you to know that over my years, problem 19 has proven to be, well, it's an optional problem. And I would say at best, I get about one person every 3 years who does the problem and gets it right. So if you're looking for a problem that involves a little bit of ingenuity and thought and interest, 19 is an excellent, challenging problem. 20 is also an excellent one to try. It also takes a little while. 17 involves the law of cosines. There's a little hint there. I made the problem up and then was really happy to see it, used somewhere else. So I was thinking along the right notes, but, yeah. So anyway, those would be good ones for you guys to try.
17 right now. Circle.
No. Like,
Just
if you,
as an
if you want
option.
to, as an optional, like, I knew you
If
were
I
gonna,
get bored.
I knew you were gonna do them all anyway,
Yeah.
so.
I mean, what else would I do
So
with my
just
life?
those ones we circled.